Let's talk about some applications of solving right triangles. So there's some terms that are used in the setup of diagrams, one of which is the pitch, in other words, like the pitch of a roof. If a builder describes the pitch of a roof as 3/8, it means that the height rises 3 feet for every horizontal change of 8 feet. And so one question that we might want to know is what does that mean in terms of the angle? So what angle theta would be related to that? And so essentially this problem relates to solving a right triangle. We have a horizontal dimension of 8, a vertical dimension of 3, and we're interested in the angle that would create a right triangle with those side lengths. Well, those two sides are related by the tangent ratio. So the tangent of theta would have to equal 3/8. And so we can use the calculator to figure out what theta is by using the inverse tangent function of 3/8. So let's make sure we're in degree mode, and we are. And then I can go and enter inverse tangent, the yellow command, the second command above tangent, and the ratio. So the inverse tangent function takes the ratio 3/8 and turns it into an angle measure. So the value of theta would be 20.6 degrees. Another term that's pretty important, or another situation that's pretty important, is that let's say you have two kind of horizontal planes. Perhaps down here at point A there's an observer, and at point B there's a hot air balloon. Then the line that goes between them is sometimes called a transversal, because it cuts across the parallel lines. And in that situation, we call the angle between the horizontal and the transversal at point A, we call that the angle of elevation. And the angle up above, the angle between the horizontal and the transversal up at angle B, that's the angle of depression. So a couple things to note here is that in this diagram, the angle of elevation and the angle of depression are going to be the same. So those two are congruent angles. And both of them are going to be between the horizontal and the transversal. And so sometimes it can be a little bit confusing, because if we're talking about, let's say we have a problem where I know that the height of the balloon, the height of point B, is maybe 105 feet. If I know that that's true, and I want to know, maybe I want to know the distance from A to B, given that the angle of depression is 28 degrees, it's important to know where that angle of depression should go. It can sometimes be confusing, and you might want to place it in between the vertical and the transversal, but that's not where it should be. It's always going to be between the horizontal and the transversal. So to solve this problem, well, we need to kind of think about what's the right triangle here. What right triangle can we set up to take advantage of the angle measurement that we have and the length that we have, provided that what we're looking for is this unknown side, the length of the transversal, the distance between A and B. There are a couple ways to kind of envision the problem. There are definitely a few ways to sort of think about it. And one would be, if this is 28 degrees, the angle of depression is 28 degrees, then the other angle, these two together have to make up 90 degrees, and so the other angle has to be 62 degrees. So one trigonometric ratio, a trigonometric ratio that we can use is not sine, but cosine. Cosine of 62 degrees is going to give us 105. the adjacent side to 62 degrees, divide it by x. And then solving for x, I can multiply both sides by x, and then divide by cosine of 62. To figure out what the value of x should be. So let's enter that into the calculator here and see what we end up with. If I take 105 divided by cosine of 62 degrees, we see that the value is 223, let's say 223.7 feet. Calvin approximated the angle of elevation to the top of a sand dune to be 24 degrees. So here's Calvin, and here's a sand dune. And he measures the angle of elevation up to that sand dune to be 24 degrees. And then he walks 500 feet closer to the sand dune, to this new point. I'll call it C prime. And then the new angle of elevation is 17 degrees more than the first. He estimates it to be 17 degrees more than the first. Again, the angle of elevation is still between the horizontal and the transversal, or the rising line. And so 17 more degrees would be 41 degrees. And we know that this distance is 500 feet. So that's the problem that I'd like to solve. But to do it, let's think of it more diagrammatically. So if I just kind of think about the triangles involved, what we really have, the information that we're given is kind of about this triangle. The top of the dune, and then C and C prime. I know this distance is 500, I know this is 24 degrees, and I know this is 41 degrees. But what I can do, because what we have information about is right triangles, I can create two right triangles by dropping sort of the vertical, and in fact that's the height that we're interested in finding. So now to solve the problem, well, it's a little bit complicated because I don't know enough about any one of these right triangles. So it would be nice if I knew this entire distance, and then I could use the 24 degrees to find the height, but I don't know that entire distance. But the thing that's missing is exactly the amount of information that I need to work with the smaller triangle. And so we can set up sort of a system of equations, a pair of equations, using the fact that tangent of 41 degrees equals h over x, and tangent of 24 degrees equals h over both of those distances, the whole distance, which is 500 plus x. So using those two equations, we can actually work through some algebra and solve for the height that we're interested in finding. So I'm going to pause here and include the answer in a separate video. I encourage you to take a few minutes to try the problem on your own and try to figure it out before you watch the solution in the next video. Thanks for watching.